Hello and welcome to my free CCNA Cisco Certified Network Associate course. Today we are going to be talking about LAN Ethernet switching basics. The objectives for today's session are: we'll understand the basic logic on which layer 2 switching works and operates on. We will learn how the switch learns the MAC address and it forwards the frame to that particular port only. Then we are going to verify the MAC addresses learned by the Cisco switch in the Cisco CLI. We will understand how we can remove these dynamically learned MAC addresses, and in the end we are going to learn about how to verify and understand the aging time of the MAC address in the memory of the device. So let's get into it. So if you had seen my video on TCP/IP fundamentals, you know that the switch is a device that is used to connect nodes within the same network. It is used to create a LAN between devices in the same physical location. Further on in the video of OSI model, you know that the switch forwards layer 2 traffic, that is frames. The frame structure is something like this. A header and trailer is added to the data. The main thing to note in the header is the destination and the source. The destination and source are the MAC addresses of the devices that are sending the data and receiving the data. The other part of the header, that is the preamble, is used for the synchronization of the data. Then comes the SFD, which stands for Start Frame Delimiter. Then comes the destination and the source, which is the MAC addresses of the source and the destination devices. Type is for IPv4 or IPv6 type of a network, as the frame header remains the same in both the IPv4 and IPv6. And the trailer consists of FCS, which is frame check sequence, which checks that the frame which has come in is correct or not. But in switching, we are going to focus on destination and source MAC addresses. So now let's see how the source and the destination MAC addresses are used by the switch for communication between the clients. Here we have 4 clients, client 1, 2, 3 and 4, connected to the switch. So we say client 1 wants to send a packet to client 3. So in this case, the source MAC address will be clients 1 and the destination MAC address will be of client 3. The switch has an internal memory table which is known as content addressable table, which basically has 2 columns. One is for MAC address and another is for port. So switch retains all the information on which port it sees which MAC address. So what happens when client 1 sends a frame to client 3 via switch? Client 1 first sends the frames to the switch. The switch first sees the frame and notices that the MAC address that has come as the source MAC address was not available in its address table. So first it registers that MAC address in its address table against a port. Now it sees the destination MAC address. The destination MAC address is not available in the address table of the switch. So switch here does something which is known as flooding. Now flooding is that because switch does not know where this 3333 ending MAC address is, it sends a frame out to each of the port. This is also known as unicast flooding. Why is it known as unicast? It is known as unicast because it is being sent 1 to 1, but the destination MAC address location is still not known. So when the packet reaches client 2, it sees that the destination MAC address is 3333. The packet is dropped here because client 2 doesn't know what is 3333 MAC address. When it reaches client 4, again the same thing happens and the packet gets dropped. But when the frame reaches client 3, the packet is now known. And since the packet is known and the client 3 spawns the frame back, and this time around the source address becomes the client 3 MAC address and the destination becomes client 1 MAC address. Now here client 3 forwards the frame back to switch. The switch sees a new MAC address in the source table. So it adds this MAC address to its table and registers the port along with it. This time around the destination MAC address is already known. So switch forwards the unicast packet to client 1 and does not forward it to client 2 or client 4. So there is no flooding or broadcast happening. So now you understand how the switch learns the MAC address, how the switch floods the MAC address, and how the switch communicates when there is a unicast frame coming into the system. Let's understand one more aspect of the switch. The switches will always create a network when connected amongst themselves, a loop-free network. So let's suppose that Mary wants to send a packet to Bob, and Bob is currently offline. So what is going to happen? When switch 3 receives a packet from Mary, it is going to broadcast it out to switch 2 and to switch 1. When the packet reaches switch 1, it is going to broadcast it out to switch 2. When the packet reaches from switch 3 to switch 2, it is going to broadcast it out to switch 1. Now the fresh packet that is received from switch 2 side to switch 1 is going to broadcast it out to switch 3. Similarly, something will happen in switch 2. What is happening is the packet is going to go around from here and around from here, and this broadcast will keep on happening and saturating the whole network, and everything is going to stop. But in switches this does not happen. This does not happen because switch uses technology known as STP, that is spanning tree protocol. That means that the switches interconnected amongst themselves will create a state where loop is not created and a linear network is created, which further simplified means that one of the networks or one of the segments will be automatically be disabled, whereas the others will be in forwarding state. This is done automatically inside the switch. We don't have to do anything. We just have to configure which interface or which segment has to be blocked or disabled by the switch. Configuration is automatic, and when a link goes down, this state automatically turns into a forwarding state. We will learn about STP in a later lesson. So let's understand the switching logic once again theoretically. So when a frame arrives at the switch, it is first decided whether it is dropped, that is, it is filtered. This action takes place because of the destination address, not the source address. So if the destination address has to be dropped, it has been configured as so, it is dropped. Otherwise, forwarding happens. How the forwarding happens? When the destination address is unknown, the frame is flooded into the system. That is, the frame will be forwarded to each of the interfaces of the switch, not the interface from where the frame came from. And if the destination is known, then the frame is forwarded to that particular port where the MAC address was last seen. But if the MAC address was seen at the same interface from where the frame is coming from, then it is not forwarded, it is dropped. Secondly, every time a frame is forwarded to the switch will examine the source MAC address, and if that MAC address is not in the table, it will register in its table, that is the content addressable memory, and this information will be stored when some other frame comes into the system which has to be forwarded to that particular MAC address. And the third and the last important point of the switching logic is that switches will create a loop-free environment with other switches using spanning tree protocol. So let's now come into our packet tracer and see all of this in action. So here we have 4 clients like we had in our diagram. That is client number 1, client number 2, client number 3 and client number 4. The MAC addresses are the same as earlier, and each of these devices have a configuration already preset, wherein client number 1 has an IP address of 192.168.0.101, client number 2 has 102, client number 3 has 103 and client number 4 has 104. So let's see this in action in packet tracer using simulation. So you can switch on the simulation from here, and now in PC1 you can go to desktop, go to command prompt, and let's do a ping to 192.168.0.103, that is our client 3, and we see the frame here. Okay, so 101 is trying to communicate to 103. So let's see what happens next. Let's move this window here. Let's shut it down. Okay, let's see what happens next. So let's start from beginning. And the first thing happens that PC1 sends a frame to the switch. Now switch, on receiving this, forwards it to all the other ports. Since this was unknown, so it is forwarded to all the other ports. So now you see that PC2 and PC4 have rejected because this MAC address is not known to them. But the MAC address was known to PC3, so it has sent a unicast now back to the switch, and the switch, because it knows where PC1 is, forwards the packet to PC1, and the ICMP packet has now completed. So packet tracer is a great tool to do simulation. You will understand how the packet traverses through the network. Let's go into the switch now, into the CLI. Let's go into the enable mode and let's see what all MAC addresses can we see here. So let's show MAC address table dynamic. So we see that on port 1 we see PC1, which is 020011111111, and on port 03 we see 3333, that is PC3. So I'm switching over to a simulated Cisco router in GNS3. A reason for that is there are some commands that are not available in packet tracer, and I would really like to show you those commands. So in small setup, show address table dynamic is okay because there are only finite number of entries, but in a large setup finding a MAC address will be very difficult. So in case the MAC address is known, what you can do is show MAC address table dynamic address, the address, and this will show you the port on which that MAC address is. Unfortunately, the address and the MAC ID is not available. This command extension is not available in packet tracer, so I'm doing it in GNS3. The another important command to know is show interface status, so you know which ports are active, connected, and which are not. So here we have 4 ports that are connected right now. All the other ports are not connected. This command works in your packet tracer, so you can use there. The address table that gets loaded into the dynamic content addressable memory is stored only for a finite amount of time. To see this time, you can use show MAC address table aging time, and we see that the global time setting is only for 300 seconds. So after 300 seconds, if there is no update coming from the client, the MAC address will be dropped from the table, and when the frame from that client comes again, the MAC address will be loaded into the table. This setting can be changed in the configuration mode by doing MAC address table. You can see aging time, and when you click question mark, it says 0 is to disable and 10 to 1 million seconds as the aging time. So you can set the time to 500 from here. Now if you go back and redo the command, you'll see that the aging time has now changed to 500 seconds. And like we did show MAC address table for a specific MAC address, we can do it for a specific interface, which could be a gigabit 0 by 0. So what all MAC addresses are there on gigabit Ethernet 0 by 0? This command comes into use when you are connected to an interface which is connected further to a switch. So gigabit Ethernet 00 is connected to a switch, and there are many MAC addresses there. To see what all MAC addresses are coming from that switch, you can use this command. And from time to time, you will need to clear the MAC address table. To clear all the table, you can do clear MAC address table dynamic, or you can clear it for interface specific, say for gigabit Ethernet 0 by 0. So this will clear all the MAC address for 0 by 0. So let's see the MAC address now. So there is no MAC address that we can see. Let's see if we can see it for 01. Okay, the MAC address I think has aged. Let's see it for 02. No. So 02 is still there, but for 00 the MAC address has gone. Now let's do this command for 02 also and see if the MAC address goes. Yes, the MAC address is now gone. We can do it for a specific MAC address also if you need to reset that specific device or user or that specific. So thank you for watching today's video. I hope that today's video you learned a little bit more about LAN Ethernet switching and how to operate your switches even more, and how to operate your packet tracer. I know that there are some commands that are not available in packet tracer and you would really love to use them. I would shortly come out with a video to install GNS3 and how to install Dynamaps images on it so that you can use the GNS3, and I'll even show you how to use actual Cisco images free of cost on Cisco CML. I'll tell you how you go about it, how you book your labs and everything. And please do subscribe to my channel to get the latest updates. Until we meet the next time, goodbye.